In this locus question, the most important thing is to draw. Without drawing, I have totally no idea what's happening here. So roughly draw the position first. If it is needed, maybe we need to update the drawing where we know more information. But we just try to draw. A is going left by 10 and then don't move up or down. So we have point A approximate here. And then B is 30, 0. So it's on the same line. 30, 0. So this is 30, while this is negative 10 here. And then what they say is a circle pass through A and B denotes the center of C by G. There is a circle, maybe like this. And the center of this circle is denoted by G. And then it's given that the y coordinate of this point is negative 50. So basically the circle should be below but not above. And then we have a center G here. It's given that the height here is negative 15. So it's something and then negative 15. One thing very important is this is horizontal line. And then for the chord AB, if we connect a line perpendicular to the chord, then it will bisect the chord, which means that we know that G, the x coordinate, should be the midpoint of AB. So the x coordinate, the center x coordinate should be negative 10 plus 30 and then divide by 2, the average between them. So it's 10 and then negative 15. We know the exact position of the center. After that, we need to know is the radius. We need to find out the radius. Then we may just simply use the distance formula to get BG. Radius is equal to BG by distance formula. That means we compare the x difference, 30 minus 10. So 30 minus 10 bracket square plus the y difference square, 0 minus negative 15 square. That means 20 square plus 15 square. Again, 3 to 4 to 5. I know the answer should be 25. It's a very common ratio that we find for Pythagoras theorem. And then to write down the equation with a center with the radius is easy to find it out. For the equation of circle, again we have a general point. And then from general point to center, the distance is always fixed. So x minus 10 bracket square plus the y difference, y plus 15 bracket square, should equal to the radius square. We have x minus 10 square plus y plus 15 square equal to r square, that means 25 square, 625. This is called the standard form of circle equations. So this is acceptable as your final answer. We finish part A. In part B, they say there is a line L pass through B and G. So draw a line for L. And then they say that there is another line, small l, which is parallel to the blue line L. So maybe it's like this. But you don't know the heights, maybe you can shift upside down. But at least they are parallel. And then just assume that it's here with a little l. And then they let P be a moving point such that the perpendicular distance from P to L is equal to perpendicular distance from that point to L. We have to find some point such that it's in the middle between these two lines. So one of the solution may be perpendicular distance, maybe P1 is here, or P2 may be here. So if you understand what is meaning, you can easily find out the locus of P is a straight line between capital L and small l. This is the locus of P. And they say that the name is inverted L. And then it's given that it's passed through A. Therefore, if we modify the graph, the locus of P is here, and then just now the small l. And the key point is that difference. Their perpendicular distance are the same. They ask us to describe the geometric relation between inverted L and L. Obvious, they are parallel, that's all. So just testing whether you understand the situation. Just simply write down this line parallel to this line. And then B2. We have to find the equation of this inverted L. This inverted L is parallel to this line and pass through this point. So because they're parallel, that's why they have the same slope, same steepness. So our target is to find out the slope of this blue line. The slope of capital L is equal to delta y to delta x. So we use these 2 points to compare. We use 0 minus negative 15. 0 minus negative 15. Then x coordinate difference is 30 minus 10. 30 minus 10. 3/4. Therefore, our target line here, the red line, since capital L parallel inverted L, therefore the slope of inverted L is equal to 3/4 also. We have all the required information, so we can write down equation of our inverted L. For straight line, always slope equal to slope. Left hand side, we use a general point xy to express it. So we compare general point to our given point here. We have y minus 0 over x plus 10 is equal to the slope that which is implied by L here with the same slope 3/4. So 4y is equal to 3x plus 30. Y is equal to 3/4x plus 30/4. That means 15/2. I prefer slope-intercept form because it gives me the shape of the line very quickly, and also I get the y coordinates, y-intercept point here. Suppose that inverted L, this line, cut C at another point. The first point, inverted L, cut the circle, is at this point. The second point is at this point. But don't mix up, it's not necessarily the y-intercept point. It's just because it's quite close. But anyway, we are talking about angle GAH, this angle here. So one of the method is, some of you may try to get the coordinate of H, but it's not necessary. Our strategy is we separate to two angles. This is the first angle. This is the second angle we need. We try to find out the angle of inclination. If we compare A with any point on L, inverted L, this is the delta y while this one is delta x. Delta y to delta x here, one view, it is the slope of inverted L. At the same time, is to this angle of inclination, this is opposite to adjacent. So you may say that is equal to tangent, the angle of inclination, which means that the slope is just tangent of that theta. Don't forget that the slope of this L is equal to 3/4. So we can get the first angle theta easily. Theta here, that means talking about angle HAB is equal to shift tangent, the slope 3/4. It's around 36.86989765 degree. And then now we focus on the blue angle here. Again, to this angle, we want to compare point A and G. It's the most convenient. The vertical distance is between 0 and 15, so delta y is 15, while the horizontal distance is between 10 and negative 10, so the horizontal distance is 20. Tangent, this angle, tangent find, or you may write tangent angle BAG. is equal to opposite 15 divided by 20. So again, BAG is equal to shift tangent 3/4. So basically they are the same. 36.869896765 something degree. And then therefore your target angle HAG is what asking, or GAH, is equal to 2 times 36. Then we get 73.7397959. The most important thing is compare with 70 degree. Is that smaller than 70 degree? No, it is larger than 70 degree. So we do not agree. That's how you can solve it. Basically, the key point is testing whether you know the slope is tangent of the angle of inclination here.